All right, still on the midterm, number 6, the investment questions. Because I gave you a formula sheet, I think the challenge with these investment questions was just making sure you were using the right formula. So if you go back, go down to the bottom here and look at all of our formulas. The challenge was looking at this thing hopefully before the test and understanding the difference between all of these guys. Only one of these formulas, is that true? I think that's true. Involves continuous compounding. That's this compound interest formula right here. So the very first one, the big hint was noticing that it says that we have all this money and we're compounding it continuously. Continuously means we have to use that formula. It was A equals P times E to the APR times Y. Make sure I copied that down using the same notation your book uses. This formula right here. And here it tells you that E equals approximately that. So if you wanted to just type in that number and use that for E throughout the problem, that's totally fine. Most calculators will have a button that does E. It has that number stored in it. So you could use that also. Anyways, P is the principal, the amount you invest, which in this case is $10,000. E, you're looking through this problem. What is E? What do I put in for E? E is a number. It's already a number. It's not specific to this problem. You don't have to plug anything in. It's that 2.718, but your calculator knows that. APR is the rate. So we have an APR of 4.5%. I think the only way you could go wrong there is if you wrote 4.5 here instead of 0.045. You got to convert to a decimal. And then Y is the years. Tell me how many years here and how much is it worth after 20 years. There you go, Y is 20. So you plug that all in here, you figure out what's 10,000 times E to the 0.045 times 20. Do that in a calculator. I got 10,000 times E, which like I said, you can type it in, or if you notice right here in yellow above the natural log key, there's this E to the X. So if you hit second and then natural log, I get 10,000 times E raised up to some power. What power do I want it raised up to? I want it raised up to the whatever 0.045 times 20 is equal to. I found that a lot of you guys like to do problems within problems. You like to first figure out what this is equal to, jot that down, and then do E to that power, jot that down. That's fine, although if those things you're jotting down are infinite decimals, then you end up rounding throughout the problem. And so as long as you carry a ton of decimal places, it's fine. But if you round off too much inside the problem, it can really affect the final answer, as we saw in a previous problem. At any rate, I hit enter. It pops out a number. That number is my answer. 25,000 and change. A lot of change. 24,000 and change. $24,596. And we want it rounded to the nearest cent, so I'll say and 3 cents. Good idea to do a little kind of gut check on these things. Wait, you invested $10,000 and you're getting interest on it. If I got $5,000 as my final answer, I would be pretty sure I'd be doing something wrong. Because wait, why are you losing money if you're investing it for 20 years? 24,000, that might seem high. I mean, that is high. It's just it takes a long time. It takes 20 years. But your 10,000 turns into 24.6, I guess, thousand. Good idea to invest early. Problem is nobody has money early. This next one, a person is 20 years old, deposits $1,000 each year into a traditional IRA for 50 years at 5% interest compounded annually and retires at age 70. How much money will be in the account upon retirement? So the first thing you gotta do is go down to your formulas and figure out what we're talking about. What I want you to notice is that it was asking you how much money. It wasn't asking you what the payment should be. So we're not talking about this formula. We're not talking about this formula. It was asking you how much money. So you're looking at one of these A equals formulas. There's just one of them that has N regular payments per year. It's this mess of a formula here. So what we want to do is copy that down. I'm going to grab some notes where I have that written down so I don't have to keep flipping back and forth between the two. And let the grader know that you're using the formula that A is equal to the payment times 1 plus your APR raised up to whatever N times Y is equal to. Then from that you want to subtract 1, and all that you want divided by the quotient of the APR and N. So if you wrote that, you probably saw a check by it. That's good. I was happy you're using the right formula. That's good. Then I go over and look at your inputs. The payment given us in the problem is $1,000. We're depositing $1,000 each year into this thing. What else do we need to know? Well, let's see. It looks like APR is one of the things that I'll have to plug in. APR is given to me in the problem, 5% interest compounded annually. So I get 0.05. Y is how many years? Let's see, a person's 20 years old, so 70 years later, or 70 years old would be 50 years later. But it actually does that calculation for you. It tells you 50 years later. N's a little bit tricky. If you go back down to that formula sheet, it tells you what N is equal to, somewhere around here. Here it is, N regular payments per year. So we're making 1 regular payment per year because we're putting this money in once a year. So N would be equal to 1. So we'll go back up here to the problem. N equals 1. Plug in all these numbers. You get 1,000 times 1 plus 0.05 raised up to the N times Y minus 1 divided by, oh, I guess to make it look just like the formula, I'll put the divided by here. 0.05 divided by 1. You don't need a lot of these ones. 1 times 50, you could have just written 50 there. 0.05 divided by 1, you could just write 0.05 if you want. Stick it into a calculator. 1,000 times 1.05. Actually, let's write it just like the formula. Parentheses 1 plus 0.05 raised up to some power. What power do you want to raise it up to? Where's my caret? There it is. Whatever 1 times 50 is. I think I can do that math in my head that it's 50. And then from that you want to subtract 1. Don't worry, this is not doing raised up to the 50 minus 1 power. The order of operations, it does the exponents before it does subtraction. So this is going to be all this stuff minus 1. Whoa. I'm actually going to need parentheses here. Because I don't want to subtract 1 after I multiply this by 1,000. I want to figure out all this, subtract 1. Later on, I'm going to multiply by 1,000. So then that I want to divide by 0.05 divided by 1, which is just 0.05. I hit enter. It kicks out some answer, some large number, 209,000. It's a lot of money. $347 and 0.9957. However, it says round it to the nearest cent. So we're going to say this is $209,348 and no cents, because you look at this 5 right here, it's 5 or greater. That bumps this up to, instead of $7.99, you get $8. This right here would be our final answer. All right, last one. There's a problem on this problem. I screwed it up. In 15 years, I want to have blah, 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 blah. How much will I have in 5 years? Whoops. This should have been a 15, or this should have been a 5. I screwed up. My mistake. I made sure that either one was correct, even if you used both in some weird way in your formula. If you did anything with either of those two numbers, if you got confused because those two numbers were different, I made sure you got the credit for it. Still graded this problem if you messed up in other ways, but I made sure that I gave everyone the benefit of the doubt on that. And sorry I made that mistake. So you can use either one. Maybe let's pretend that this really said 15 right here and do the problem. Although if you did the problem with 5 here and here, totally fine. I give you full credit. In 15 years, I want to have this much money. How much should I deposit? This question is asking for a payment. This question is a lot like Part B, except in Part B, it gave me the payment, asked me how much I'd have. This one is saying, you want to end up with this much money. What should your payment be? So you go down to the formulas, and you got 2 of them that tell you payments. You got this one solves for payment. and this one solve for payment. This is your monthly payments to reach a goal. Like if you want to have $50,000 in a certain amount of years, this is the one we want to use. This one's a little bit different. It's similar, but these are loan payments. It's like if you owe so much money, how much should you pay if you borrowed money from somebody? So I am going to use this top guy here. And I'll write it right here. Maybe I can do it in green. That formula was that the payment is equal to A times APR divided by N divided by, it's a mess of a formula, 1 plus APR divided by N raised up to whatever N times Y is equal to. And that whole thing, you subtract 1 from it. This is the formula I'm going to use. So I need to plug in all the right numbers. A, the accumulated amount. Well, let's see. I want to end up with $50,000. So that would be 50,000. APR. That's this 3.5%. So make sure you round, or you make that a decimal, 0.035. N. Remember, N is the number of payments per year. These are monthly deposits, so our N will be a 12. Y is the amount of years. This could be 5 or 15 because I screwed this problem up. Maybe I'll write 15 or 5 right here. We decided we're going to use 15, or I just decided right now, but either of these answers were fine. And if you put in 5, well, whatever. Either answer was fine. So we plug all these into a calculator. Let's see, so we got A, which was $50,000, the amount I want to end up with. And then I want to multiply that by APR divided by, so 0.035 divided by N, which is 12. And then I want that to get divided by, so all these division signs can be kind of complicated. You don't need these parentheses, but I'm going to put them in there just to try to make things more clear. So 50,000 times something. What do you want to multiply it by? Well, something divided by something. The top something is this. The bottom something is 1 plus my APR 0.035 divided by N, which is 12. Note that I started 2 parentheses here because I want 1 so I can raise this entire thing up to the N times Y power. N is 12, Y is either 15 or 5. So I want to raise it up to this power. Then once I get that answer, I want to subtract 1, which is why I needed this second set of parentheses so that I'll divide by this entire thing. If I hit enter right here, I'll get my answer, $211.61 if I round it off. This is a good spot to do a reality check. I think I mentioned that earlier. If you deposited $200 every month, so let's see, that's what, $2,000, $2,500 or so every year for 15 years, 2,000 plus for 15 years. So you're putting in over $30,000, would you end up with 50,000 with the interest? Sure, that makes sense. But some people got answers here like 200,000 or something, or $8 or something crazy like that. Like it would be nice if you just put in $8. That'd be awesome. Put in $8 every month and end up with 50 grand, but that doesn't really make sense. So it's a good idea to do a reality check on these numbers because if they're wrong, you probably just missed a little parenthesis somewhere in here. However, if anybody wrote out all this and had this crazy was off, I think I took off 2 of the, I gave you almost full credit for it, so it's not something to worry too much about. All right, there's the end of that problem.